And good afternoon, everyone, or I guess good morning if you're on the West Coast. Thanks for joining us. My name is Zach Allison with ATS. I'm our National Accounts Manager, helping engineers navigate our free online spec tools, helping them understand the products that are available on there. And one of the ways that we do that is our ATS University series that we've run. I was telling Lauren in the kind of the intro session there, we've run these ATS universities for coming up on 5 years now. So it's been a lot of great content, all recorded and available for you on atspec.com. At the end of the presentation, I'll show you how you can find some of the products that we discussed today. I'll show you how you can find the recordings. And if you need any help afterwards getting started, feel free to reach out to me, my team. We're happy to show you how you can navigate the system, provide you one-on-ones with understanding how to make product selections for the great products that we're talking today. With us today is one of the manufacturers that sponsor the ATS spec tool so that we can provide these great tools to you free of charge. From the Bradford White team, Lauren's here to go over heat pumps. But I believe this is going to mostly be non-branded, I assume, because this is an ASPE accredited presentation today, right?
Yes.
All right, so we don't get to get into the actual good stuff, the nitty-gritty, and understand the individual product, but we're gonna have a, I guess, conceptual overview of heat pump water heaters.
Yes.
Perfect. So a couple of pieces of housekeeping before we dive in. Obviously, everyone pretty familiar with Zoom and webinars these days. We have everyone muted upon entry, but I'm happy to take questions. So if you have questions along the way, pop them into the chat field or the Q&A field. I will bring them up to Lauren when we get to a nice pause point, so we can kind of address any questions while we're still on the relevant topic. And of course, regarding your accreditation, this is ASPE accredited CEU. In addition to your typical ATS certificate of attendance for any sort of self-reporting, and engineering groups that you might be party with, we're going to send over the attendance list to Lauren, who will get the ASPE accredited CEUs out to you guys so you can tick off the mark for your credits. I think that covers just about everything in terms of the housekeeping side. So without any further ado, I'll pass it over to you. Thanks for joining us today.
Okay. Perfect. Thanks, Zach. Good morning or good afternoon, everyone, depending on where you're located. As Zach mentioned, my name is Lauren Baronato, and I'm with Bradford White. I am based out of just outside Philadelphia, Pennsylvania. That is where our corporate headquarters are. We do have a Bradford White Canada office, and I saw that Graham Gilbert, who is our Canadian connection for calling on engineers in our Canadian market, he is on the call today as well. So it's great to have his support for today's presentation. But as Zach mentioned, today's presentation is a CEU class, meaning it is not branded. The only brand you will see is our logo at the bottom. Otherwise, this is entirely just for educational purposes. We are not pitching Bradford White product. One of the things that's good or bad about CEUs being brand neutral is that they tend to be a little boring. I will try to make it the least amount of sleepiness as possible today. I really tried to engage. If anyone has questions, you can either enter them in the chat and Zach will moderate. I think that's the best way of doing it. And then he can control to unmute someone. But this presentation was created back 2 years ago. So this mainly focuses on residential, I would say more than commercial applications, but goes into the thought process behind heat pump design and gets into the topics a little bit more as to refrigerant as well as other aspects. It does follow ASPE's standard format. I promise I will not keep any of you past 1 o'clock. I'll shoot to wrap up the presentation like by 12:45 or 12:50. So that way I know Zach mentioned he'll show the website a little bit, where to find our product offering, answer any questions, things like that. So I promise I will stay on time. But thank you all for being here today. And also just a side note for ASPE, I know ASPE does have a couple locations in Canada. I'm super involved with ASPE in the United States. I sit on the Region 1 board, as well as the Philadelphia board. So if anyone has any ASPE questions, please feel free to reach out. So learning objectives. What do we want to do here today? What are the goals for today? So we want to understand how a hybrid electric heat pump water heater works and why it's significant in the US market. I guess it really can take place from the Northeast, sorry, North American market, because I do think the trends that go on in Canada are very similar to the trends that go on in the United States as well. Understand how a heat pump water heater uses the same principles of refrigeration to move heat rather than create heat. That's the really big thing about heat pumps is that you're moving heat, and that's what causes them to be so cost effective as well as efficient. We're going to talk about identifying proper site selection as well as a typical installation that you will see, debug some common myths in the industry about heat pumps, know the varying refrigerant types that are utilized, have a basic understanding of commercial heat pump water heaters, and have a basic understanding of sizing and application. So I will say here in the beginning, the challenge with heat pump sizing and application commercially is no manufacturer has a sizing software on their website for you to size. Everything is based off of the engineer or designer utilizing their own guidelines to develop the best process, I should say, for sizing their heat pump on their own using the math calculations from ASPE as well as ASHRAE guidelines. So you're really going to have to hone in on the installation manual that is present when you're specifying your product. Another thing that could be a challenge if you specify a heat pump today, but the job doesn't go on for 18 months to 36 months from now, designs could change. So just keep an eye on that, especially contact the manufacturer, contact your local rep who's representing the water heater manufacturer, as well as look at the specification sheets. The specification sheets will be up to date. They will tell you what to do with sizing, but that's been one of the biggest things that we have noticed is that the unit itself has been changing for some manufacturers between specification as well as installation. So what's being installed could be slightly different than what you specified. Now, if we were in a live audience, we're all in the same room. This is when I typically be like, so has anyone installed a heat pump? Have you specified them? Are waiting to see what goes on? Those are like typically the questions that I would ask. So for those of you at home, or in the office, if you're familiar with them, if you're starting to get questions about it. But
I'll volunteer. I have not installed one, but I have had, the trend is certainly upwards, momentum for heat pump specifications. We're getting asked a lot more often for them. It's not always the
yeah.
right option, but it's very consistently becoming a lot more frequent.
Yes. And I think the thing too that's been going on with heat pumps is that we're seeing a lot of inquiries come in and building owners hear about the cost efficiency for a heat pump and they want that to be installed because it is incredibly cost efficient. However, the upfront cost is very expensive. It's often 4 to 7 times the cost of a standard electric water heater. So do you want to pay that upfront cost to get the payback in the end? So where we are seeing heat pumps go to be installed, especially on the larger size, the ones that would be going on the roof of your building, like your CO2 style heat pump, we're seeing them installed on universities, healthcare, as well as government projects that are receiving some type of subsidy for using electrification and heat pump technology. The reason for that being is a lot of buildings here in the States, and I have to imagine in Canada as well, are trying to be zero carbon emissions by a certain date, and that heat pump will definitely help them get towards that goal. So with this presentation, we kind of take you back a little bit to see where this all started and go through the basic terminology of how this came to be. So simply just identifying electrification, that is the process of replacing technologies that use fossil fuels with electricity as a source of energy. And then we'll talk about decarbonization, and that is where you're reducing a carbon footprint of a business with a focus on efficiency gains, renewable energy, and minimize waste. So these are some images that were taken from the Department of Energy's website, just showing you how this operates. It's interesting. In the States, we actually have data as to how much each state produces their own energy versus brings in energy from others, and it ranks them 1 through 50. So that way we can tell which states are really assisting and ones that are really just not able to suffice on their own and have to get their sources of energy elsewhere. So just something interesting that you can look into. So how did water heaters become the focus? It seems kind of random why all of a sudden is this the target? Was water heating what really got on the mindset of those in the DOE as well as the EPA to really figure out what's going on with water heating? So this pie chart right here gives a breakdown of expenses incurred in United States homes. Water heating, you can see there it's 18%, can account for anywhere from 14 to 18% of home utility bills. That is the breakdown we see, and that's why that has become the focus. Now, some people ask, why is it space heating? Because that takes up 45% of the total cost for your home utility bills. Why is that not the focus? And the reason for that being is that it takes a lot more heat to heat a water heater than it does to heat a boiler. So that is why we will often see this. This is just a statistics that $400 to $600 is the amount of money the average household spends on water heating each year. To me, that sounds kind of low. I think we definitely spend more money. Judging by my personal electric bills, I'm guessing that we experience higher costs than that. But that is just a sample. Now, one of the things too that I know is interesting about your market, especially for homes, is that you are very much more tank lift style heating for water heaters at home. So that's just a different trend. Definitely is picking up in popularity here in the United States, but for the most part, it is tank type water heating is what we see as the prevalent style of water heater in the United States. So like, where did this all come from? How did this even get started? So in the 1970s and the 1980s, early concepts and prototypes started to emerge with heat pumps. Heat pump water heaters first came out during the energy crisis as an experimental high efficiency alternative to conventional electric and gas models. There was drawbacks with these designs. The designs were really bulky, often unreliable, and limiting with widespread adoption. So Energy Star launched in 1992 here in the States. It was launched by the EPA as a voluntary labeling program to identify and promote energy efficiency. So the goal here was to reduce greenhouse gas emissions, and computers and monitors were the first two pieces that were rated. So those were the first rated products that we saw here in the States. Is it the same in Canada? Do you have your own version of the EPA?
Uh, so we have similar programs that require Energy Star rating, um, and different governmental initiatives that have the Energy Star requirements. Or
Okay.
yeah, I
Okay,
don't know
cool.
what it's even called. I don't know if we have the EPA, like a
Yeah.
Canadian version of EPA, or just our certifications follow along with it.
Yeah. So EPA for us is the Environmental Protection Agency. Been making a lot of news lately about the EPA. So that's the other thing that's interesting is given the current political climate in the United States that seems to be moving away from, oh, it looks like one comment came up. Moving away from eliminating greenhouse emissions or carbon emissions. So we'll see how things parlay. I was going to say, I noticed there was a notification that popped up.
Don't have to get distracted. I'll bring it up.
Oh, okay. Okay,
Yeah,
cool.
someone was mentioning that it's NRCan, which is, I believe that's correct. Yeah, Natural
Okay, cool.
Resources Canada.
So in 1995, that's when the first HVAC product was rated, and that was because it was the highest energy user in a home. Water heaters did not get rated until 2009. So relatively new for water heaters being rated. It hasn't even been 20 years. But going back to the 2000s, that's when commercialization and Energy Star certification really took off. What it did is it improved compressor technology as well as refrigerants, which enabled more compact and reliable systems. Um, and then again in 2009, that's when heat pump water heaters were first rated with Energy Star. So that gave a boost in credibility as well as reliability to lean towards market growth. Now, from 2010 until today, that is really where hybrid designs and smart integration came into play. What is a hybrid model? It's both a heat pump as well as it has electric resistance for backup. So it can run off of pure heat pump mode, it can run off electric mode, it can run off a hybrid of the two, it can also run off a vacation mode. We'll get into those modes in a little bit throughout the presentation, but these basically allowed it to have heat pump performance be better in cold climates to provide better user flexibility. Modern heat pump water heaters now include smart controls, demand response features, and integration with home energy systems, aligning well with electrification and decarbonization efforts. I think one of the things too to keep in mind with heat pumps, and one of the challenges with an outdoor installed heat pump, is the ambient air temperature for efficiency. For a residential heat pump, for example, often has to be above 35 degrees Fahrenheit. And for a CO2 unit of a heat pump, they really perform best anywhere from -10 degrees Fahrenheit to 0 degrees Fahrenheit. So to have your heat pump running as efficiently as possible, it has to have the best ambient air temperatures around it. So what exactly are reasons why heat pumps became the preferred design? Like, how did this really even come to be? So one of the things that really came into play was the energy efficiency as well as cost savings. Heat pump water heaters are 2 to 4 times more efficient than your standard electric resistance water heaters because they move heat rather than generate heat. They have that lower operating cost because of that high efficiency. So it can typically have savings of anywhere from $300 to $500 or $300 to $600 a year, depending on and usage. For Energy Star ratings, most models qualify for Energy Star, making them eligible for utility rebates as well as tax incentives. Tax incentives are one of the leading drivers here in the States for people installing heat pump water heaters in their home, is because of the financial break that they get through the installation of this appliance. Now, you'll also look into carbon reduction as well as environmental impact. By using ambient air to heat water, the heat pump water heater dramatically cuts out greenhouse gas emissions compared to fossil fuel based or resistance elements. Now, we also want to look into grid decarbonization energy. So in the US, grid transitions to cleaner energy, such as wind and solar, electric heat pump water heaters align with this fully for national decarbonization goals, amplifying environmental benefits over time. Now, one of the things that's a challenge here in the States is that while we are moving towards electrification, our energy grids are not set up to fully support the new demand that's going to be going on electric. So a lot of updates are going on here in the States to improve our electric grids. In New York, for example, New York City and New York State, any new construction commercially has to utilize electric heating for water heaters and no longer can have gas. So now we're running huge buildings off of electricity that used to previously be run off of gas for heating. So just an example of the way our older cities, the way that the structure is set up, that it has to really involve renovations and updates to the grid. There's also federal and state incentives that are reasoning why heat pump water heater is the preferred design. So we have the Inflation Reduction Act that offered up to $2,000 in federal tax credits for the Energy Star certification for heat pump water heaters. And then we also have our state and utility programs. Many states and utilities offer additional rebates, some over $1,500 or more, making heat pump water heaters increasingly affordable for homeowners. The biggest incentive I have heard has been in California, where the rebate was around $8,000 if you installed a heat pump water heater. That was for commercial application. So lots and lots of rebates are coming in play as the reason to get specifiers moving, as well as get as contractors in for installing these heat pumps. Now, 3 more reasons. One is for building codes and electrification push. So for policy support, we have both national and local policies that are increasingly favoring electrification. For heat pump mandates, again, I mentioned a lot, it's tough. A lot of the stuff is repetitive for reasons as to what, it's all really intertwined. I feel like so much of it is between rebates as well as codes based on city, county, or state, or possibly federal to a point for the DOE 2026 standards, which I'll mention right here, as to what caused this real focus towards heat pump water heaters. The DOE 2026 standards, that is coming up for efficiency standards here in the United States. It goes into effect on October 6th of 2026. What is so unique about this is that it's the first time in about over 15 years that the DOE is really starting to regulate the efficiency of water heaters. And it's eliminating any product with a thermal efficiency below 95%. So where you see this is atmospheric venting. For example, for gas water heaters will pretty much be entirely eliminated because atmospheric vents typically have a thermal efficiency of anywhere between a 60 to an 80. Certain high efficiency gas models need to be completely updated due to their thermal efficiency, that needs to be higher to meet that 95% threshold. The good thing is about these standards is that they come into effect of date of manufacture is October 6th. It's not date of install and it is not date of specification. So as long as the product has been manufactured before October 6th of 2026, it can be installed on a project. We have a whole separate CEU on the DOE standards and changes that are going on. I just was finishing working on it because we're presenting it at the ASPE Tech Symposium in September. So really that's going to affect design mainly with retrofit. The majority of engineers and designers on today's call already are specifying the most thermally efficient methods for gas water heating and today. But it really comes down to if you're, let's say you're in an older city like Boston or some parts of Montreal or Quebec City, and you are replacing an atmospheric water heater and you have to replace it with something that is not what was there because it's no longer thermally efficient. So you're going with something that's going to be power direct. Then that starts the whole new thing of how exactly do you vent this to be as efficient as possible, but also within staying in the parameters of design. And unfortunately, no water heater manufacturer for gas product has the same venting length. So if you pulled out, let's say type A manufacturer, you can't put type B type manufacturer and it can't be an easy swap. You have to check your vent lengths for everything. That's where specifications are really key. Having contractors trained on product is really key. So that's really where it's going to come into play. These standards will not be affected residentially until 2029 here in the United States. But I always say it's like, you already have so much going on of keeping track of codes and standards and new product updates and new alloys and all of these things. And now it's like, oh, there's a whole new code standard that everyone has to be in compliant with. That's making waves throughout manufacturing. It's making waves throughout construction. It's making waves throughout specification. So it's really affecting so much. But the energy efficiency of the grid is not there yet to fully support it. So it's and in a good way, it's like, yes, we want to have the best thermal efficiency for all of our products. However, the cost of these thermally efficient products that perform the best are significantly more expensive than the atmospheric unit that has a 60 to an 80% thermal efficiency. So sorry to go off on the DOE tangent there a little bit, but it definitely is relevant for what's going on today and the way that designers are designing. So for technical advancements and versatility, we have hybrid functionality. These systems combine heat with heat pump technology with electric resistance backup, allowing for better performance in cold climates or higher demands. Wi-Fi connectability is something that we've seen a lot of customers asking for. Many models do include smart controls enabling load shifting and demand response. It's important for grid stability and time of use savings. Another thing too, I think, is if it's a second home and you want to know what's going on with your water heater, that's one of the things where Wi-Fi connectability is key. But last, for the reasons why heat pump water heaters are becoming preferred designs, is for growing market opportunity. The replacement market, over 8 million water heaters are replaced annually in the United States. Converting even in a fraction of those to heat pump water heaters has massive potential for energy savings. We also have long-term growth. So market share is expected to grow significantly due to rising consumer awareness, evolving regulations, and enhanced financial incentives. I know the engineers on the call, sometimes it's a little bit of a challenge when your building owner says, we want X, but that doesn't necessarily make sense of the design, but you want to comply with the building owner so you get the job. So I think that's one of the challenges too, is like, what are people hearing and why do they want to install it? So getting back to terminology, I know we did a little bit on decarbonization as well as electrification, but just to get on heat pump water heater technology and terminology is heat pump water heaters. You'll see abbreviated here at some of the lingo used. You also have a unitized heat pump water heater. That is one piece, same look, ready to install, no HVAC license. That is often where you will see it in a residential piece. I know it's non-proprietary presentation, but it's something that we offer as a single piece unitized heat pump water heater. One of the biggest pieces of feedback we get is that engineers are used to having a design where you have your low boy water heater and then your air handler unit above it. You cannot do that with a heat pump because the heat pump will take up that entire space. So it's really changing the way you design maintenance rooms and when you are designing maintenance and facilities rooms and when you are designing for mixed use residential, the biggest piece of moneymaker for you is space. So now we're taking more space that's not livable space because it's your utility closet. So that has been a challenge for designers. That's when you really want to look at the venting options where you can duct out to ambient air outside of the louver door. So we also have split systems. So that's a split system heat pump water heater. That's a two-piece system where your tank is inside, but your heat pump water heater is outside. That will typically use CO2 to operate at a lower ambient temps. This is much more expensive. This is, I think, where the market will be going, is that this is a bit more easier to design for. So I think we're going to see a larger increase in manufacturers coming out with their own split system heat pump water heaters. Now, I like to talk about hybrid electric water heaters because for heat pumps, this is something that we really see. I mentioned this a little bit earlier of the 4 different modes that you often see with heat pump water heaters, but for heat pump only, that will maximize your savings. For hybrid mode, that will save you money by also experiencing a faster recovery. The heat pump recovery is very slow, can be 10 hours or greater to fully recover your tank. For electric, it operates like a standard electric water heater. And then last is vacation mode, so that will drop your tank temperature down. We often see it to 90 degrees Fahrenheit is what we are seeing for that. But another reason why people are preferring a split system for the heat pumps is because it has a quieter indoor operation. Since the fan and the compressor of the heat pump are outside of the living space, and it's the split system will be quieter indoors, your water heater heat pump often has a decibel level the same as you would hear of a dishwasher. She's like, oh, the dishwasher's pretty quiet. Like, I don't really notice even when it's running. Sometimes you don't even know when it's running, and then you open it and it is running, right? We have had that happen depending on how new your dishwasher is. That's how it is at my parents' house. But your dishwasher is not sitting next to your bedroom in the utility closet. You're not hearing it running 24/7. It typically runs once a day, once every few days, whereas your heat pump water heater will be running much more frequent. So that's something that all manufacturers are working on is having that be a quieter operation. Now, one of the things too about heat pump water heaters is that you really need to make sure you're properly sizing your tank. So with this, heat pump water heater has a standard electric water heater with a heat pump. Residential gas water heaters typically have a higher first hour rating compared to the electric water heater. And therefore you need to have a larger electric tank maybe needed to compensate. When heat pump sizes are poorly done, they will perform, I'm sorry, when heat pump sizes are designed properly, they will perform just as well. But if they are not sized properly, you're going to have a challenge with making sure that you have that hot water demand being met. I mentioned this at the start of my presentation, but you really want to follow the manufacturer's specific sizing guidelines. Every manufacturer will be different, but really keep a close eye on that. Here again is just some examples of what you would like to likely consider for your heat pump sizing, what type of tools you need to know. Again, very similar the way you would size an electric water heater. However, it is different when it comes to the amount of air and space needed. Heat pumps are proven technologies. You'll find them all around your air conditioners, freezers, and refrigerators. I think the best example of what is similar to a heat pump is a window unit air conditioner. You put it in your window, hot air is on the outside, cool air is coming in. It's the exact same technology with air movement for a heat pump water heater. It's just instead it's taking your warm air and producing warm water. So how exactly does a heat pump work? This is a very simple image, but it basically shows you how the heat absorption or evaporation occurs. And that's the heat pump pulling your heat from surrounding air using refrigerant that absorbs its thermal energy. And this will happen with cool air as well, not just warm air. Then you have your heat compression. That's where the refrigerant is then compressed, increasing its temperature significantly as it moves throughout your system. And then last, we have the heat transfer or condensation. That is a high temperature refrigerant, which transfers heat to the water in the tank through a coil or a heat exchanger, efficiently heating your water. Now, this next slide I think is really great because it basically shows you the internals of a heat pump once you take the jacket off of it, what it looks like underneath. So you can see right there on the top of the system. And again, this is a single unit. So the heat pump is at the top, but it identifies where the heat pump is, where your evaporator draws in ambient heat using a fan. Your evaporator will absorb the heat, and the compressor increases the temperature and pressure of the R134A refrigerant. Now, R341A refrigerant is no longer allowed in HVAC products. It is still allowed in plumbing products. We are not aware of any area where it will be not allowed anytime soon, but it's a bit confusing because we often get from the engineers that are both mechanical engineers as well as plumbing designers. What about this 134A? When is it getting eliminated? It's actually not. But as soon as it's announced that it will, we will obviously design around that. But for right now, our designs still have this product in there.
Yeah, there's got to be so much confusion there for you guys after dealing with like on the HVAC side, all the refrigerant issues they've had from the last year's update. I
Yes,
would imagine you get a lot of cross contamination and confusion.
100%, 100%. Yeah, so we'll talk about different refrigerant types too as the presentation goes on. But you can also see here external condenser coils. Heated refrigerant will flow through the coils to heat the water in your tank. The coils are external and surrounded by the porcelain lined tank to prevent corrosion. Can take temperature up to 140 degrees in this model. Again, both tank and electric elements. We've pretty much gone through all of this, so I will skim through it. But this slide just lets you show the efficiency with an example of being light bulbs used. So basically it takes 5.5 incandescent 100-watt light bulbs to the same electricity for heating a heat pump water heater versus an electric heater, it would be 45. So just showing you the drastic reduction in energy.
So just jumping back to that kind of breakdown of the heat pump water heater slide, there's a note from the chat asking, regarding vacation mode. And this is something that's come up for, storage type water heaters as well as heat pump water heaters. But, with that vacation mode, that kind of lowers the temperature in the tank. Do all heat pump water heaters have that mode? And how does that affect, Legionella control? Because Legionella is a primary concern when it comes to water heater temperatures, distribution temperatures, everything like that. There's a lot of talk around how do we control for Legionella. So how does that affect the
Yeah,
inside
yeah.
of the tank?
So really, really good question. So the challenge with Legionella is it's constantly breeding. It obviously gets instantly killed at 158 degrees Fahrenheit or above, but once you are below that temperature threshold, it's going to be sitting there, right? It's going to be sitting there growing in your tank with some type of bacteria growth. I think the most important thing to remember, oh, so first vacation mode, is that on all units? I don't know. I know for residential it is, and it drops it down to around 90 degrees Fahrenheit. I'm not an expert in all manufacturers' products. I would assume it is, just because typically with these types of things, if one person has it, then all of a sudden everyone has it. I always give the comparison to having Wi-Fi in my kitchen stove or my kitchen oven. Like we have Wi-Fi access, so I can set the temperature of our oven while we're still at the grocery store. Do I need that? Absolutely not. But do I love it? Of course I do. So I think that's what it like comes down to is with that piece as well. And
I do
also
that with
giving
my
it time that
smoker
if it
as
is in
well.
vacation mode, you know when you're coming back to increase it. Now, who is watching their time that close for a residential water heater to see how much they're spending on money with a heat pump? Is it even necessary? Is it even efficient? I think that would be a different study. But so Legionella prevention. So most water heaters in a commercial setting are stored at 140 degrees Fahrenheit. If you're going to do a thermal disinfection, you will run it up higher through typically you'll either use your main heater and have that go all the way up, or you will typically have some type of booster heater throughout that will also have it go up to 160 degrees Fahrenheit. I think for commercial designs, I know here in the United States, there's mixed opinion as to how to design. You have the CVC's guidelines that basically identify 8 different areas that would be potentially susceptible to Legionella. And if you look at these 8 different areas, it's pretty much every single piece of building that you would be designing for. For example, one of them says if construction is going on close by. Where isn't construction going on close by, especially in the summer months, right? So it's like, how do we design for this? What do we do? So when it comes to your commercial building, you're going to want to make sure that you have a water maintenance plan in for the Legionella disinfection. You also need to think of yourself, to yourself, excuse me, where would someone be susceptible to Legionella? It's not going to be when you're having a glass of water, but it will be when you're in your shower because the only way for you to contract Legionella is through aerosolized droplets. So where are we being exposed to those aerosolized droplets that we're going to be inhaling them? It would be steam in your shower, possibly steam off your kitchen sink if your kitchen sink is running really hot. Those misters that you'll see in the summer months to like cool things down and mist, that's basically just spreading Legionnaire's disease potentially everywhere. So like interesting, like do you want to be cool or if you're immunocompromised, maybe don't sit near them. So I think that's really where it comes into play. But I agree because you're looking at this and you're like, well, I can set my heater lower. Is that safe? Is that not safe? So it's really weighing the risk factors. If you are the engineer signing off on the drawing, I would not put it in vacation mode. You do not want to be open to litigation possibly because of the recommendation you give. If you look at energy code here in the United States, I'm assuming it's the same in Canada, you are told to turn your pump off at night in commercial buildings to not have your water recirculating. If you look at OSHA, which is basically our government agency that oversees that workplaces are safe, they say do not turn the pump off, because if you turn the pump off, then you are subjecting your employees to Legionnaire's disease exposure. So I think it's something to be mindful of, maybe something to take note of, where you recommend, like, say, water heaters should be stored at 140 degrees and go from there just to cover your end of it. That would be my recommendation.
Well, and I will comment, just vacation mode has become a thing across many manufacturers. And again, not just heat pumps, but in storage type water heaters as well. It's not every water heater, usually it's a selling feature, but it ties into the last part you made, having a plan.
Yeah.
Because yeah, if you were doing, schools started doing this for a while before summer school really became even more prevalent. But when schools would have a 4-month break or a break over Christmas, you would put it into an economy mode, reduce your temperatures, but then that ties into a, welcome back. We've got to burn everything off and have a, high temp flush. You know,
Yes.
um, it really does tie into it all in all. Office buildings as well, when they were going through periods of low attendance there for a few years, there was a welcome back to the office, but your building needed a welcome back first. So
Yeah.
having a plan for the water maintenance is absolutely tied to any sort of energy savings you're getting with vacation mode or economy mode or whatever you have.
Exactly. And also it's like, are you doing a chloramine flush? Are you doing a chlorine flush? Like, what are you doing of your system? I think that's something that comes into play, is like there's so many steps to prevent Legionnaires. And it's also, is Legionnaires
Okay.
increasing in diagnosis, or are we just doing a better job of, is it being increased more because we're doing a much better job of identifying it versus a pneumonia versus COVID? That's the other thing, was like things could have been misdiagnosed before and now they're accurately being diagnosed as Legionnaire's disease. So, but
And plus,
really
like
good
a
question.
decade ago, we were, storing at 120. Maybe you'd get, distribute at 120, and then, you learn about, all these other factors. So then there's the balance between scalding and Legionnaire control. So you could talk about Legionella forever. So I
Forever,
think we'll let you get back to
forever,
it.
forever.
But
Yeah.
great question. Obviously, we both really enjoy that topic.
Yeah. Yeah. This is just showing you the payoffs for heat pumps. The site actually needs to be updated. Heat pumps are now at 4.2 or higher for UEF rating. So and UEF / thermal efficiency rating. So you can see compared to a tankless unit or an atmospheric, that's put down at a 0.6. So just examples of the benefits of having a heat pump water heater installed. Best locations for heat pump water heaters, garages are really popular. The reason for this being is the open air, as well as heat pumps will often cool the temperature of a room anywhere from 3 degrees to 5 degrees. All depends on your climate. If it's warm, it's really great to have it be cooler. If it's cool, it's not great to have it be cooler. So it really comes down to that. Basement, closet, laundry room. Just make sure that if you are in a closet, similar to the same way you would for an atmospheric venting, that you have a full louver door to have proper airflow going through. What's the same as a standard electric? These are just a slide comparison showing you the same volume size for a first hour delivery for heat pump water heaters, as well as that it's designed for installation in a similar footprint as your standard electric units. Again, you just have to remember the heat pump above makes it that if you're designing for residential, you no longer can put a low boy and a air handling unit. These next couple slides just kind of show you the differences and the similarities for just the physical observation of the physical setup of the differences between the heat pump water heaters as well as the standard electric. This information you can take off of all of the unique specification sheets that you see based off of what you're specifying. Again, differences for airspace requirement was never really a consideration before for standard electric. Clearance for service. Again, look at your installation manuals, look at your specification sheets to see where that will come into play. Again, more questions about this. The air filter is pretty cool. That does need to be cleaned periodically. What's nice about that is that it will identify you in the app or whatever feature you're using to be identified for the heat pump status. That needs to be cleaned, as well as it will make a noise. There's just information more on the condensate drain line. A couple examples of typical installations that we'll see for heat pump water heaters. Again, this is from 2 years ago. So heat pumps were becoming prevalent, but are definitely more prevalent in the market now. But just showing you the airspace requirement for typical installations. You can see garages, looks like an attic, looks like a basement. As I mentioned, make sure you're reading the installation manual. Cannot emphasize this enough. This is what will have it be successful. You can see here it's modeling the differences between a louvered door versus a non-louvered door, and letting you know the varying aspects of install. So for ducting, this is a nice feature. Most manufacturers do have ducting kits available for heat pump water heaters. So you will have, I mentioned the 3 to 5 degree temperature depth. So with ducting, you can pull the air from outside to have the air internally or externally, can be putting the air elsewhere, which is a nice feature. So common myths about heat pumps. I have a feeling we probably went over all of these. I'm just gonna make sure that we have. Cost is expensive. The rebates will help them pay for themselves. Need to have a refrigerant technician. No, you don't. That not for install. It's only if you're servicing. You must prevent the condensate from freezing. The water heater should switch modes to properly function in electric mode if it's noticing that temperature dip. It works in garages, as we mentioned. It makes too much noise. And I mentioned how it's similar to a dishwasher. So fact or fiction there, that one's a little gray. It doesn't work in cold climates, not true. It works anywhere from 35 to up to 120 degrees Fahrenheit of ambient air. Challenging to install. Has either top or side connections depending on your manufacturer. Does not make enough hot water. That is not true. It produces the exact same amount of hot water as a standard electric heater. Now, if you said doesn't make enough hot water fast enough, that would be a different story, because that's talking about speed versus capabilities. So I think that's the thing, like incredibly efficient, just a little bit slow. Now, getting into commercial heat pumps, what exactly is a commercial heat pump system? Basically, it's systems in a building of 4-unit dwellings or larger. Commercial loads with greater than 120 gallons of storage are needed. As I mentioned earlier, you will often see split systems for this. So you will have a large heat pump or multiple heat pumps, and then large storage tanks to support that. What are the advantages here? We mentioned these a little bit already, but installation flexibility is huge. This will allow you to separate the heat pump from the water tank, so allowing engineers to place the components where they work best, such as a heat pump outside or on a roof. It's really critical for where you're having space-constrained mechanical rooms or retrofit applications. Improved efficiency in diverse climates. The outdoor unit can draw heat from ambient air year-round, which is a huge advantage, optimizing performance even in the cooler months. It will keep the water tank indoors, helps maintain water temperature stability, so that reduces standby loss. And then also reduce noise and heat load indoors. Commercial spaces often need quiet operation and controlled indoor climates. So by placing that compressor fan outside, it will minimize your indoor noise as well as excessive heat. Bottom line, split system heat pumps or water heaters is where we're giving commercial building owners as well as the engineers design flexibility. I think that's what we're really looking for, is more flexible solutions, and that you will find with your split system. Now, I know we mentioned a little bit about refrigerants and what is being outlawed. So 134A, very much used residentially for heat pumps. It's non-flammable. It's stable with good efficiency. Not good because it has a high global warming potential. You will also see 744A, or 744, which is your CO2 or your carbon dioxide. You'll see that for your high efficiency commercial systems. It has a very low global warming potential, which is popular. However, it operates at a higher pressure, which requires a special design. We also have your 401A, which is used in some residential as well as commercial HVAC style systems. Pros are that it's efficient and widely available. Cons is that it does have that greater global warming potential. So it is being phased down under certain regulations. And then we have a R290, which is emerging for next generation heat pumps, especially in Europe, but it's just started to make its way into the United States. Very low global warming potential. However, it is flammable, so it requires very careful design. So how natural refrigerant heat pumps work, these images right here depict that. It's a little tough because some of the color on the screen is yellow. But basically it's just showing the different phase changes that occur within the heat pump from when it goes into evaporation, compression, and cooling expansion. So looking for the differing refrigerant style, as then when you're looking at the basic R744 heat pump, just showing you where you have your hot water system indoor, and then you have the rest of your heat pump parts that are outdoor, or could be outdoor or indoor, but for the most part, you're going to want them to be outdoor just because of the size of them. So again, this is just showing the different ways that the heat pump refrigerant operates. Now, for CO2 natural refrigerant heat pump for refrigerant to domestic hot water, this is where we're seeing it's basically showing the differing ways that the refrigerant will travel into your heat exchanger and transfer heat to your domestic water. That's the biggest thing that we want is the transfer of heat based off of the movement of heat versus creation of heat. So you have your cold domestic water that enters your heat exchanger to be heated by hot refrigerant, and then your refrigerant will travel into the heat exchanger and transfer heat to domestic hot water. It's very much coming into thermodynamics. So whatever class you took junior year or sophomore year is becoming very prevalent in your career versus the, I don't know, 3 months that you might have spent on it at university. So that's one of the thing about the heat pump design is that it really is basically using the thermal efficiency to properly heat your water. Um, just more slides going on identifying how synthetic refrigerant operates differently from CO2 natural refrigerant, talking about the subcritical results that occur within these refrigerants, as well as transcritical, which will allow for variable temperature management across a heat exchanger. And then you also have differences in your heat transfer optimization. So you can see here the performance and flow of CO2 versus the synthetic. And then basically showing the differences how transaction transcritical CO2 cycles have inherent advantages where large temperature lifts exist for the fluid being heated. Exact application type for volume water heating, cold water heated to very hot water is where you will typically see that. Now, typically a heat pump and tank system is what we will see. So commercial split system heat pumps do require a central tank system. That is your storage tank that's needed for your heater to operate properly. Again, talking about time length of recharging, it can take around 12 to 18 hours. So when you think about an office building, when your office building is not being occupied, but when you think about a hotel or a dormitory, you don't necessarily have that time to fully recharge because those areas definitely require hot water accessible more often. Now, just talking about some of the pros for plumbing applications and some of the cons that might be. For pros, reduce mechanical room heat gain. Since the compressor's outside, it won't reject the heat indoors, so helpful for maintaining climate control. For cons, control complexity, for example, staging and controls are more complex than conventional water heaters, especially when balancing with mixing valves or backup heaters. You've got your cold weather considerations for your in colder climates. The outdoor unit would require a defrost cycle or backup heat. And it does have that higher first cost. I think that's one of the things that has been sticker shock to building owners is why am I paying this much more money for this water heater when electric would just do the same? But for overall carbon emissions, the heat pump will have much less overall carbon emissions.
So we had a question come in, and I guess maybe you tell me where this fits into pros versus cons. Um, about like, is there a distance limitation or a maximum distance that, for these split systems, where I guess you could be, have your heat pump side away from your storage tank side.
Yeah.
You mentioned
I
one
don't
refrigerant
know
one.
if there is any limitation. I my gut tells me no, just because as long as it's piped properly, it should be fine. But let me check with our product team to see if there is distant limitations between the storage and the split system heat pump water heater. Is that the correct question?
Yeah.
Okay.
Yeah. So we'll reach out to the person that had asked it after we hear back from you as well.
Okay, cool. So application examples, these are just a few examples that our team put together showing where a heat pump would operate for sizing. Um, two primary loads for a multifamily building example, for example, two loads to consider your primary load. So for heating cold water for use and storage, and then also for temperature maintenance for reheating distribution loop water. So just kind of going into size protocols, which everyone on this call, if they're an engineer and designer, should be familiar with. Determine the hot water requirement, occupants, how much water they use, design conditions, for example. And then you'll want to take into calculate the heating loss in the recirculation loop. This is just showing you the load profile for design day versus average day. I know most engineers design for worst case scenario, especially with their groundwater temperature. You typically will size for your winter months, not your summer months. So basically here you'll see gas-fired systems are sized with a small storage, large heat source. Exact opposite. Heat pump systems are large storage and small heat source. This is just kind of calculating the differences that you can see of a heat pump technology versus a gas offering. So you'll see here, there's a lot more components going on with your heat pump. You have 4 heat pumps, 3 storage tanks, as well as a backup electric. Versus gas, you will have 2 large volume water heaters and then 2 storage. So it's just kind of showing the differing. I think this like physical image really helps about imagining the mechanical room and seeing the difference in size and units that are there. This is just kind of going through that multifamily building example. It's just showing the tank volume, the swing tank volume, the different heating capacities, as well as the swing resistance element. So for CO2 units for cold climates, one of the things that is nice about this is that you can store your water at a higher temperature of all the way up to 180 degrees Fahrenheit. Now, that is not always best practice, as it will likely be too hard on the materials that it's coming in contact with from your line. So you likely will have it being that it's tempering down, but your synthetic refrigerant operate at a maximum water temperature of 150 to 160, and then it will also drop down again to 15 and 40 degrees when your incoming air temperature is in that range. The R744 will not be phased out over timeline like chemical refrigerants often are. For CO2 heat pump considerations, you are going to look for double wall gas coolers for heat exchanger built in, otherwise an external double wall for walled water, and look for a fully charged plug and play. Now, one of the things that is a challenge with CO2 units is that if you are servicing them in the field, it does require a contractor that has a certification in operating with CO2 because the pressure is so high. So I don't know if any of you on the call today have already installed these large units. That's the CO2 units that you'll see on like the roof of a building because they take up so much space. But something that can be a challenge is having the contractor available to service a system in the field. So it's 5 of, so I'm finishing up right now. So that is all I have for you all on an introduction to heat pump. But thank you so much for your time. You do not have to send me your name and your email address to get a CEU credit. ATS will do that. So I will hopefully put in these credits early next week. So thank you all so much for your time today.
Absolutely. And what I'll do is actually I'll take over screen share, and if you want to
Sure.
come up over, you can take a look at any additional questions that have come in. Maybe you can, answer while I get going here. But yeah, that was great. Thank you very much. If there's any additional questions, I understand people are probably gonna be needing to drop off shortly. Certainly feel free to stick around, see how you can find some of the products that we talked about today. That's what we'll be covering here. The ATS spec tool, sponsored by Bradford White for the US territory. Lots of great product available to help you make your selections on water heaters, storage type, gas, electric, heat pumps. I'm sure tankless everything that's available from the BW lineup getting added in here. So we've got a number of previously recorded sessions. In fact, we were talking about the refrigerant session. We did a great session with the First Co team earlier in the year where they broke down the changes to that HVAC refrigerant side. So we don't want to tie any confusion, but if you want to learn more about that, you can go to our previously recorded sessions here in our webinar recordings, and you'll also be able to access this presentation there by the end of the week. If you're unfamiliar with ATS Spec Tool, again, free design support tool to assist engineers actually configure your product, get the accurate model name and number, and then download the format. And I think we've got 9. We're working on 2 or 3 additional ones, hopefully coming out this year. 9 different ways currently that you can download the information and put it into your specs, however your firm delivers a project. Some firms prefer Excel fixture schedules on the drawings. Some firms prefer, we've got three different types of Word formats depending on the level of detail you put into your spec. Multiple PDF documents, Revit files. Again, lots of firms do products different ways. We're here to support and tie into however you do it. Your account is associated with your firm, which allows you to do things like store masters on the system and have your team all work off the same master spec for their individual project or for their quick selection. So if you are leading your plumbing team and you have an EIT join, you can be confident that they are working off of your approved master. Really helpful for onboarding new people, helpful for making sure your spec stays up to date. Let's say 2 years from now, there is a change to the refrigerant for the plumbing side. When Bradford White tells us, hey, we've got this change coming, this model number is going to be updated, this verbiage needs to be updated. And if that product is in your master, you will be advised, hey, this product in XYZ master needs a updated selection. It's out of date. It's not accurate anymore. Our goal is to help prevent change notices, and that's one of the key elements of having your master. It's not going to remove your internal current processes, but it keeps it up to date and helps you ensure all of your team is working off the same approved product selection. And you don't have to go and remove, 5 different types of models. Instead, you're going to start with creating a quick spec, a project, or as I mentioned, the master. We'll create a quick spec really quick. If we're just looking for a heat pump, pop in a title. It can be your fixture tag. It can be your project name, whatever it is. You can see I've got my pinned favorite categories here. I'm going to bop into the water heater category. And we've got all our different products here. We, of course, have, there's links to sizing tools. We can search for the Aerotherm, find our Aerotherm water heater. We've got the 80 here, 65, 50 as referenced. If we're unsure which model we need, we can pop open the manufacturer's spec sheet, do some additional research and understand the products. All that same information is embedded here within your features. So you got all the details there, shows you recovery. You can then configure and select your options. So one thing we'll highlight, we've got our general model number here. And if we want the Bradford White Connect kit or our ducting kit, we are, as we say, configuring the model number. You're getting exactly what you specify so that you have less issues, less change notices in your project. ATS also builds what we call a fixture chain. So even in those images, we saw the heat pump and we saw it with everything else that you need for the project. So you might need a expansion tank selection. We can find either size and select or hit an unsize for a general model. Again, if we go to reset this, we could select our actual size if we've sized this offside. But we can also skip this if we're doing another manufacturer's expansion tank, or if we are not using an expansion tank because there's one existing. No problem, hit complete, bypass it, and then just go straight to generate the spec documents where you can download submittals, schedules, 3 different versions of Word specs, the manufacturer's spec sheet, Revit files. If you're doing things like faucets and sinks, you may want the brochure format. I don't often find that water heaters need the fancy big picture, nice pretty images and the short details, but it's available if you want it. You just hit generate spec documents and it's going to put all that into a zip folder. I always anticipate that we're going to be a little over time, so I've pre-downloaded some of the formats here. So, we've got a written spec here, CSI format. This will match if you follow the 3-part spec format. Description, model name and number, everything's open and editable, so you can add in, copy and paste, revise whatever it is you need. And then you can also get the submittal format. Shows all the critical information that you would need again. And if you want the more detailed manufacturer spec sheet. So these are both serving different purposes. Your manufacturer spec sheet is great because it has all those additional details on dimensions. Whereas the submittal format is going to be customized to your specific model name and number again. So it's like having something that's already checked off the boxes on that manufacturer spec sheet, because that's what we're doing. I'll show the Excel file here as well. Schedule, again, this can be copied directly into your CAD schedule. And then we can bop back to our quick spec. Other piece I wanted to show really quick here. So this is, the next level of detail. We created a quick spec. It was just a title. There's no location, nothing like that. When we set up a project, we're adding a location. The location is going to tie to building code. If there are specific models that are not allowed in Dallas, Texas, especially when it comes to barrier-free, there might be different barrier-free codes or flow rate codes that are dictating your product selection. And that is built into our rule engine to make sure that if you are working on a project in California for the first time, your flow rates are going to be reduced, or your options are reduced on certain products. You also select a bid date of when you're going to tender with the document. Again, up until October 10th here, because that's the date that we've selected, you're going to get accurate model name and number. If there's a change tomorrow, you'll be notified this product's been discontinued and replaced with this one, or this product has a change to a key product detail. Here's an updated spec. We will assist in keeping your spec updated so that you have reduced change notices. The other piece that you have is from this add drawing button, we can again go back to the category page that we talked about earlier, where you can see again, I've pinned my favorite categories. I could search for other categories if I wanted. So storage tanks, water heaters, um, you know, heck, we even talked about the HVAC, so you could find your PTAC heaters or anything like that. But we'll go back in the water heater category. Again, you've got that sizing tool here. We've got, again, the ability to configure our actual selection. So we'll select we'll go with the steel tank construction. We don't need the AFME warranty on this one. We'll go with a common vent kit. And then again, updated model name and number, exactly what we selected, so we know that our specs are accurate. Hit add product, and then we can hit complete. So as easy and fast as it is configured that way, shockingly, that's actually the slow way these days. If you go to that same add drawing button, we have masters and templates here. So masters, as I mentioned before, these could be your firm's specific masters, either broken down by application, or you may have one overall master that's updated annually. We have some firms that have specific owner groups, like they're doing the Starbucks chain, or they're doing Zach's Fried Chicken chain, and there's a standard of products on here. This will help keep it up to date, but also allow, again, that EIT to come in, find exactly what's approved, drag and drop it into your current project, and then download immediately. So that would be your masters. And then we have the ATS templates, which is our recommendations by application. This is essentially the ATS masters. So you can see we've got a number of different masters there. We can filter this down to just the applications that fit the project file we're showing. We can go into our US Office master, or a Class B or Class A Office master. We can go to our mechanical equipment, find our, we've got everything from emergency fixtures, pumps, backflow, find our water heater, drag and drop. We could take the entire mechanical equipment option as well, select all. Maybe we know on this particular job we don't need a water softener, so we're just going to drag everything other than that water softener over. And now we can again download in a matter of minutes, 14, 16 different files, all up to date, accurate, configured to what you need for that job. If you need to revise a thing or two, we can always hit the edit button. If we're changing our sizes, we want to go from the 80 gallon down to the 6, we'll hit the edit button. Find again that aerotherm, and switch it over to that 65 gallon version. And we're done. We've revised our model in a matter of seconds. So instead of deleting everything, trying to find specific details, making sure it all matches, this is what we hope is a little bit easier. We hope it adds improved accuracy, improved quality to your spec delivery process. If you want any more information on that, a deeper dive, obviously that's the very quick once over demo. Happy to assist. So reach out to me. I'll get you in touch with my team. We can either review your current mouse master, help you build it on the spec tool, help you get set up. Hopefully we'll have Lauren back again for that presentation that you mentioned. If you're doing that September, sounds like you should be back here in October.
We'll see. Thank you so much.
Yeah, thank you very much today. We'll send you over the list. Thank you all those that attended and joined us. Hopefully you learned something about heat pumps and you'll join us again next week. Have a great
Thank
day.
you.
Bye for now.
Bye.